So today we're looking at a two-day lesson. We're going to do part one today. Just kind of introducing the graphs of exponential functions a little bit. So our goal today is going to be graphing exponential functions, which you guys know hopefully from last time look like this, right? Part of that process is you guys are going to need to identify what your Y-intercept is. That's where it touches the Y-axis, and also these things have a horizontal asymptote, so hopefully you'll be able to identify where that is as well. And we're going to bring back the limit notation if we get some time. Kind of get you guys refamiliarized with that a little bit. It was a little bumpy the first time you saw it, and we'll keep doing it, and hopefully it'll be a little bit easier as we go along. But what limit notation is going to do for us today? It's going to tell us about the end behavior of the function, like what's going on at the far left and far right. Okay. So go ahead and read this little scenario here for me for a second and ponder your answer. I'll give you a few moments. So you guys got any answers out there? What do you think? 4 or 5? Any other opinions? 2. What makes you think 4 or 5 then? 2 to 1. Okay. Good. And why do you say 2? Okay. Okay. So that's fine. I could see that. Now, so I thought that might be one way of looking at it too. Now, what I want you guys to see it though is a little bit different. I want you to see it as more like what John was saying, where it's like, so he jumps half the distance, right? So like before he does any hops at all, right? Say 0 hops, his distance from the pond is 16, right? And after he does 1 hop, that's half the distance, right? That would be 8. Now for the second hop, what he's going to do is he's going to only jump half the distance that remains. So how far is he going to hop this time? 4, right? So now he's 4 feet away from the pond. Does that make sense? And the question was how many times we reach, and John hypothesized like 4 or 5. And I think that's realistic, and I think that's reasonable. But now what we want to do is we want to step out of the physical world for a minute and get into the ideological world of mathematics. Does anybody have a different answer?
He never reaches the pond.
He would never reach the pond. Why? Because, check it out. What's his next hop going to be? 2, right? And then next hop? Next hop? Next hop? What's half a half? 125. And so you would have to divide forever, and you guys can get your calculator out and try it and just keep trying. Divide by 2, divide by 2, divide by 2. You'll never get to 0. It's impossible. It does get smaller and smaller, but you would never get to 0. So I guess technically the frog would never make it to the pond. He would have to jump an infinite number of times to reach 0. Okay, it's a weird idea, isn't it? Is this an exponential function, and how can you tell? I'll just say yes it is, right? Because that's obvious, because that's what we're studying right now. But how can you tell if this is exponential?
Doesn't reach 0.
That's a good point. I'm looking more for like what we were talking about yesterday, though. We're dividing, which is really, you can, instead of saying dividing by 2 every time, what you could do is you could say you're multiplying by 0.5 every time, right? So you're multiplying by 0.5. Because what the definition I gave you guys for an exponential function yesterday was that it's a function where it changes by repeated multiplication of a common factor. Okay, so what would the function of this? What would this function be? That the starting amount is 16, right? What's the growth factor? 0.5. And there's our formula for that frog's journey. Okay? And in order for him to reach a distance of 0, he would have to jump an infinite number of times. Okay? So there's that. Now, what I want to do is I want to look at a graph of this thing really quick. So we have, we're going to make hops be the x-axis, and we're going to make distance be the y-axis. So if he's done 0 hops, then he's up here at 16, right? We'll call that 16 right there. And after he does 1 hop, he's half the distance now. So if this is 16, then this would be about 8 high, right? And on the second hop, he's now half of that, which would be like here. And on the third hop, he would be at 2, 1, 0.5. And what's happening here is he's getting closer and closer to 0 as we go along, but he's never getting there. But what do we call a line that you get closer and closer to, but you never reach? An asymptote. Okay? So, exponential functions look a little bit like this. They can look like this, or they can look like this for today. And tomorrow we'll see they can also have some other perspectives. But they both have a horizontal asymptote where they're basically getting closer and closer to a certain y value. Okay? Would you say this represents an exponential growth or an exponential decay? It's a decay because it's getting smaller, right? The distance is decreasing. And so notice that my line is going down as the x increases, right? Whereas if you had one like this, as x increases, the y is going up, that would be a growth. This is a decay. How can you tell by looking at this equation here that it's a exponential decay?
The growth rate, which is the one in parentheses, lower than 1.
Good, okay. I'm going to change your word by a little bit, but you're right. The growth factor is less than 1. The growth factor is less than 1. So anytime your growth factor is less than 1, it's going to be going downwards. Okay. So now, just to kind of get you guys refamiliarized with some limit notation here, because that was kind of a bumpy trail for us last time we embarked on it. Let's try to ease you into it a little bit. As the number of hops increases, what happens to the distance? The distance between the frog and the pond, what happens? It gets smaller, right? And let's be more specific. It gets closer and closer to what? Give me a number. The distance, it's getting closer and closer to 0, right? Okay, so now there's that. So I'm going to show you guys something, a different way to write this instead of writing it as a sentence. But this makes sense to you, right? As the number of hops increases, the distance between the frog and the pond approaches 0, right? And so here's how we would write that mathematically to save ourselves some time. H represents hops. H is getting bigger and bigger. It's approaching infinity, right? The distance is approaching 0, right? So as h approaches infinity, d approaches 0. Limit notation looks like this. You write the word limit. You take this and you put it underneath. This one goes here. And instead of an arrow, we usually just put an equal sign. But that's what that means. And if you guys, I remember last time, it was just really hard for us to kind of grasp that, but I'm trying to help you guys understand a little bit better here. So as the number of hops increases, the distance gets closer to 0. That's what this is saying here. As the number of hops increases, the distance goes to 0. Okay? So that's limit notation. All right, so that's it. So today we're going to be looking at, once again, we're looking at graphs of exponential functions, and we want to be able to, after you graph them, you should be able to find the y-intercept where it touches the y-axis, and also you should be able to tell me where the y or the horizontal asymptote is at, what line is it approaching, and then we're gonna just kind of let you guys practice that limit notation a little bit more for those of you guys that are interested in moving into calculus next year. That practice will help. So let's go ahead and begin with a guided practice here. Number 1, we're going to say y is equal to, this is where you want to start writing if you haven't been so far. Okay, so part A, I'm going to break this up into some steps. Is this exponential growth or decay? What do you guys think? This would be decay. And we should probably put a reason, because the growth factor .4 is less than 1. Okay, it's less than 1. Remember our formula yesterday was like 1 plus or minus r. So if that's 0.4, then what did I subtract? I must have obviously subtracted something away from 1, right? And when you subtract, that's decay. So what did I subtract, by the way, from this to get 0.4? Huh? 0.6. If you add 1 and you subtract 0.6 away, what are you left with? So my growth rate was 0.6, in other words, 60%. And what I'm left with as a growth factor is 0.4, and that's why it's a decay. All right. There were some questions like that on your homework, and I wanted to get some questions like that yesterday, but I thought, oh, let's just kind of think through it because we ran out of time. Not a huge deal, but thought we would at least mention it there. All right, so part B. What that means is we would expect to see that the numbers are getting smaller and smaller, right? So you guys are going to use your calculators now, and you're going to complete this table for me, okay? I can do one with you, just in case you're not sure what I'm asking, but all right. So y is equal to, what was it? It was 2 times 0.4 to the x power. So if I want to do the first row here, what I'm going to do is I'm going to plug in 10, right? And you got to be careful. You know, you might be tempted to do some mental math here, and you're going to do like 0.4 times 10 and think it's 4, but that's not right. It's 0.4 to the 10th power. So you want to use your calculators. So let me open my calculator on up here. So I'm going to do 2 parentheses 0.4 close parentheses power of parentheses 10 equals. Okay, so let's interpret what this means. So it says 2 point. Oh, I lost it. It says 2 point. It's going to keep doing that apparently. 2.09, and then you guys see that little e with the -4. What that means, that's scientific notation. So what that means is times 10 to the -4. So what was it? 2 point what? 09? Okay. 2.09, and it's times 10 to the -4 is what that meant. And so what that means is this is actually a really small number. You're going to move this decimal here 4 spaces to the right. So it would look like this. That is an extremely small number, right? Oops. All right. So why don't you guys go ahead and use your calculators now and do these other ones here. And I'll call on you in a minute, and you guys can tell me what you get, all right? up here. That was an 8. But you know what? Here's what I'm going to do. I goofed and I did positive 10, you guys, instead of negative 10. I was supposed to do negative. So what I'm going to do is I'm going to go ahead and we'll drop that out from here. And I'm just going to replace this 8 down here with a 10. And I'll put it here. Sorry about my little goof up there. But so you guys, what did you guys get for negative 3? 31.25 is right. So if you got that, then you're doing it well. So keep going there. So I just wanted you guys to do that for the sake of getting that calculator practicing, because I know that typing it in sometimes is a little bit of an issue. But there's that. So let's we're going to graph it now. And I told you guys that if you were done, you can kind of get a head start. But let's go ahead and do the graph. Now don't worry, I'm not going to make you guys graph them all like this. This is a very painstakingly long process. I'm going to show you a very, very fast way. You could literally be done graphing these in about 10 seconds, once you really get used to it. You don't have to do all this. But what we're looking at right now is patterns, and so we can get to that place. So our y-axis needs to go up to 31.25 at least, and our x-axis needs to go from -3 to 10. Okay, and for y, I guess I'll just count by 2's, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 4, 6, 8, 32. Okay, so at -3, we're way up here at 31.25. For -2, we're at 12.5, so 2, 4, 6, 8, 10, 12. And we're just estimating approximately where these dots are at because we can't really be that precise. And I'm just going to continue. -1 is 5. 0 is 2. 1 is 0.8. And after that, the numbers are just really small, and what that means is we're just getting closer and closer to the y-axis, just like on that frog problem. So it's never going to get to the y-axis, but it's just going to get closer and closer to it, to where you really can't even tell it's not touching it, even though it's not. Okay, so there's our graph. Okay. Now, one thing I want to point out to you guys is, what's the y-intercept? 2. Okay, and you guys remember our equation was this, right? What's the starting amount? 2. That's your y-intercept. So in the future, you don't really need to plug in 0. You can, but that number is going to be your y-intercept. Now that's going to be different tomorrow, but for today, that number there tells you your y-intercept. Okay. All right. So there's one thing, and in case you haven't noticed, for today's problems, all day today, our horizontal asymptote is going to be the y-axis. But once again, that'll change tomorrow. Okay. So there's our graph, and see how it's going down like we would expect because the growth factor is less than 1. All right. So we're gonna do the same thing here that we did last time. So as x gets bigger, y gets what? So as my x value is getting bigger and bigger, my y value is getting really close to what? 0. So I want you guys to fill in these blanks for me here. Give you a second. So what am I going to put in this blank, you guys? As x gets bigger, that means x is approaching infinity. Bigger means it's just getting bigger without stopping ever, so that means infinity. All right. As x gets bigger, y what? goes to 0. Now we're going to write it in limit notation. What goes here? And here? Now all this stuff that I'm putting here, you guys, that's just to help you understand. This is the answer, okay? I want you guys to know how to write things in limit notation. All right. We're going to do one more like that, and then after that I'm going to give you guys a shortcut. So I'm going to go back. Okay, so for this one we're going to do y equals 3, 1.9 to the x. Same question, but I'm not going to write the questions this time. So growth or decay? This is growth because my growth factor is 1.9. B, was that the table? Let's do a table. We're going to do guess we could do negative 10, negative 6, negative 3, negative 2, negative 1, 0, 1, 2, and 3. Okay, I'm going to have, can you guys do negative 10 for me? And then you guys do negative 6. You guys do negative 3, negative 2, negative 1, 0. And you guys do 1 for me here, Braden and Amanda. So go ahead and calculate that really quick, and I'll do the last 2. And then I'll call on you guys to share out your answers. I'll ask one person from each row. What's your row? You're here. I think I gave you guys 1, 0, negative 1. Okay, so I'm going to put mine up. I'm getting 20.577 and 10.83. And Ashley, what did you get for your number?
It's in the notation form, so did I change it? Okay, so 0.00489.
Like that?
Yeah.
Okay. And Steve, you agree? Okay. Abdul, what'd you get for yours?
0.0627.
Okay. What do you think, George? Is that good? Okay. What did you get, Matt?
0.43 seconds.
So it's the same thing, just with a 4 here instead?
I think.
Okay. And I got a shaking head there, so that's good. Nick, what'd you get?
1.171875.
Okay.
Which I didn't know where you wanted me to
Yeah,
put it.
yeah. Well, when you're graphing, pretty much the tenths is good enough.
Okay, so
About
about
1.2-ish. That'll work. I'll just leave it like that, but that'll work. What do you guys think in this row? Is that good? 1.17? I'm not getting any disagreements. But okay. How about negative 1? What'd you get there, Sitlali? Okay. What do you think? Good. What'd you get? And that makes sense, right? Our Y-intercept starting point. 1, what'd you get over there, Amanda? 5.7? Okay.
Mr. Bailey, or you move to like 0.83.
0.88.
83
Like, so say it again.
for negative 2.
For negative 2,
0.83.
the answer is 0.83. That's what you got? Okay. So, Nick,
Yeah, hold on, I'm trying to figure out what I messed up.
okay.
Because that's what I get now. too.
I got a few nodded heads over there, so it looks like it's 0.83. All right, so we're going to go ahead and graph this, and we're going to see something a little bit different this time. We're going from -10 up to +3. And my y-axis is going up to 20, so I'll go by 2's again. 6, 8, 10, 12, 14, 16, 18. All right, so at -10, we're really close to what? Yeah. So I'm just going to put it basically right on the line at -10. And this is still really close to 0 at -6. So 1, 2, 3, 4, 5, 6. Still pretty darn close to 0. Still pretty darn close to 0 even at 3. 0.83. Okay, that's pretty close to 1 now. So I'd say by the time we get up to 2, we're getting closer to 1. So I'm going to pick the dot up a little bit. 1.58 for -1. A little higher. And then finally we're at 3 by the time we get to 0. 2 is 5.7. Oh, I forgot I was counting by 2's though. Oh well. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. All right, so at 1, we are going to be at 5.7. At 2, we're going to be 10.83. And then at 3, we're going to be way up here at 20. Notice that this graph is a little bit different than the last one, because instead of going down as we move to the right, it's going up. So what's my y-intercept? 3, just like we said. What's the horizontal asymptote? It's 0 again. Y equals 0. So that's the same. So we're getting kind of close to our shortcut that I'm going to share with you guys now. But this number tells you your y-intercept. We know that for today our horizontal asymptote is always going to be 0. The only thing we're left with is the shape of the graph and which way it's going. But we'll get to that in a second. Some of you guys might already know. But I want you guys to get used to the limit notation here. Now, for this one, as x gets bigger and bigger, so look at your chart here. As x gets bigger and bigger, you guys, what's happening to the y values? They're getting bigger. Okay, so check this out. As x gets bigger, what do I put for bigger? As x gets bigger, what's happening to my y values? They are getting bigger. What am I going to put here? As I move to the right, as x gets bigger, I go up because y is getting bigger. That was different than the last one, right? But check this out. What about if I go backwards? As x gets smaller, right? As I go from a +3 all the way up to -10, now what's happening to my y values?
Smaller.
Y is getting smaller, but now there's a little bit of a difference. X is getting smaller, more and more and more negative, right? And yes, y is getting smaller, but it's getting closer and closer to an actual number, 0. Okay? It's not going to ever get past 0. So how would I write that? As x gets smaller forever, what am I going to put here? If this is x is getting bigger forever, what am I going to put for x is getting smaller forever? Negative infinity. As x gets smaller and smaller, y gets closer and closer to 0. Okay, I forgot to do both sides of the graph on the last one that I did, but I think you guys are kind of getting the idea. So let's call this D, the end behavior. Okay, so I'll leave that up there for a little bit in case somebody's still writing. Okay. So let's call this example 1, part A. So we're not going to make this take so long anymore. We're going to speed it up. Ready? So this is what your homework looks like. What's the y-intercept? It's 4. It's that number right there. 2. What is the horizontal asymptote? It's been the same all day today. What has it been? 0. Now it's a flat horizontal line, so that's y equals 0. Y is approaching 0, right? So my horizontal asymptote is y equals 0. All right? Number 3, growth or decay? And why is it decay? The growth factor is less than 1. Okay, now with what we saw today is that when it's decay, our graph goes like this, right? But when it's growth, our graph goes like this. For our notes, I'm going to put since the growth factor is less than 1. So since our growth factor is less than 1, it's a decay, and it will look like this when we graph it. We have enough information to graph it. We don't need to plug in numbers anymore. We can just get this process rolling. And I think that's number 4. Let's go ahead and graph it. So let me show you guys how to graph it. Ready? What was my y-intercept? So everybody plot a y-intercept really quick. What is my horizontal asymptote? So I'm going to highlight mine. Y equals 0 is just the x-axis. And was it growth or decay? So it's going to look like that. And what we're doing is we're just going to ghetto this a little bit. We're just going to do this. We're not going to be real precise. That's good enough. So long as you hit your y-intercept, you get closer and closer to your horizontal asymptote, and it's going down because it's decay, you're good. So you're looking at 3 things just to get this thing graphed quickly without having to plug in a whole bunch of dots. Y-intercept, asymptote, direction. Pretty quick, right? The last thing you guys will see on your homework is this, though. They'll want the end behavior. We want to do from the left, and we also want to do it as x goes to bigger and bigger. So look at your graph. You can tell as x gets more and more negative. In other words, as I move to the left, what's happening to the y value? As I move to the left, my y value is, what's happening to my y value? It's going up, which means it's getting bigger. As my x value gets bigger and bigger, meaning as I move to the right, as I go to the right, my y value is getting closer and closer to that horizontal asymptote. So as x gets bigger and bigger, what's my y value getting closer and closer to? 0. Okay, so that's what your homework looks like. You just have like a bunch of problems like that. Okay? You want to try one? Hello. Nice. Okay, so I want you guys to find me the y-intercept. I want you guys to tell me the horizontal asymptote. I want you guys to decide, is it growth or decay? And based on that, you should know the shape of the graph. Then I want you guys to graph it. And then I want you guys to fill in these blanks here. try that one out. I'll give you a few moments. What's the... I'm going to call on random people. I don't have my cards ready yet. I'm not ready for my new semester, so I'm just randomly calling up people here. Steve, what's the y-intercept here? 2. George, what's the horizontal asymptote?
0.
Good. We're going to say y equals 0. And for today, it'll always be that. Malak, is this growth or decay? All right, that's okay. Well, let me see if maybe Gabriel can tell us. Gabriel, growth or decay? It is growth. Now, why is it growth? Because this number is bigger than 1. If it's less than 1, then it's going to be decay. So now we're ready to graph it. So your guys' graph should have looked something like this. You should have had a y-intercept at 2. And the graph's going to look like this. And this is my horizontal asymptote. So it's going to go upwards in that direction because it's growth. Okay? So from the graph now, we should be able to tell what these are. Giovanni, what did you get for negative infinity? Well, for this one, I mean. Huh? Infinity? 0. So this means I'm moving which direction, guys? I'm going left. As I go to the left, I'm getting closer and closer to that asymptote, right? And what's my asymptote? 0. Now, this means I'm moving in what direction?
Right.
That means I'm going to the right. So as I move to the right, I'm not getting closer to an asymptote, but what is happening to my y values? They're getting bigger. They're just going up and up and up. Okay? So. Okay. We're still struggling on the limit notation a little bit, I think. That's okay. It's an abstract concept. Hard to grasp. We'll keep messing with it. All right. That's it.